In this video, we are going to see how to draw an ellipse. So first to see the question. The question is construct an ellipse with the distance of the focus from the directrix as 30 mm and eccentricity as 2 by 3. Also draw normal and tangent to the curve at a point 40 mm from the directrix. First you write the given data. The distance between the focus and the directrix is 50 mm and the eccentricity value is 2 by 3, and they are also asked to draw the normal and tangent at the point 40 mm from the directrix. So first we need to check the eccentricity value. Here the eccentricity value is given in the problem 2 by 3. So 2 by 3 is equal to 0.66. So this value is less than 1. The eccentricity is less than 1. So the given curve is ellipse. Now we are going to start to draw the ellipse. At first, you draw the directrix line. The name of this line is a directrix, and draw the axis line. So the name of this line is axis line. Okay, and in this problem, the distance between the directrix and the focus is 50 mm. So from the directrix line, I mark the distance from the directrix and focus is 50 mm. So this is the point, fixed point. The name is a focus point. And now we need to mark the vertex point of the ellipse. So in the question, the eccentricity value is given. E is equal to 2 by 3. We need to add the numerator and denominator. 2 plus 3 is equal to 5. Okay. So we need to divide the line from the directrix to the focus into 5 equal parts. So I give the name at this the intersection of directrix and axis line is C. Now I'm going to divide the distance between C and F into 5 equal parts. So the distance between C and F is equal to 50 mm. So 50 divided by 5 equal to 10 mm. So by using your scale, you divide the line into 5 equal parts: 1, 2, 3, 4, and 5. So now I'm going to mark the vertex point. If you consider the numerator value for the eccentricity E is equal to 2 by 3, in the numerator the value 2 is there, and in the denominator the value is 3 is there. If you consider the numerator value, that means 2 means from the focus point, second division, 1 and 2. So this point is considered as vertex point. So through this point, you draw one vertical line. Draw one vertical line. And now, by help of the compass, measure the distance between V and F. Measure the distance between V and F and trace a small curve. Trace a small curve. And at this point, I give the name S. So the distance between V and F is equal to V and S. Now you connect S and C and draw one straight line. Now from the vertex point, I am going to divide the line into some equal divisions. So I'm going to divide the line by 10 mm. So first 10. So this is first division, and the next division 20, and the next division is 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, so 130. So like this, I divide the line and I give the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Like this, I give the numbers, and from all the points, I'm going to draw a straight line. And then I'm going to give the number at this place 1, 1 dash, 2, 2 dash, 3, 3 dash, 4, 4 dash, 5, 5 dash, 6, 6 dash, 7. After finishing the numbers, then take your compass and measure the distance between 1 and 1 dash. Measure distance between 1 and 1 dash and place the compass F is the center point and make a arc on the line 1 and 1 dash. Above the axis, you make one arc, and below the axis, you make one arc. And next, measure the distance between 2 and 2 dash line, 2 and 2 dash line, and make the arc above the axis and below the axis. And next, measure the distance 3 and 3 dash and place the compass on the focus point and make a arc on the 3 and 3 dash line above and below the axis. And measure the distance 4 and 4 dash and place the compass F is the center and make a arc on the 4 and 4 dash line above and below the axis. And next measure the distance 5 and 5 dash line and place the compass on the focus point and cut the arc on the above the axis and below the axis. And next measure the distance C and C 6 and 6 dash. Okay, so like you measure all the lines and make an arc on the above and below the axis. And finally measure the distance 13 and 13 dash and place the compass on the focus point. And here the compass does not meet the line. Okay, so here the arc is coming on the axis. Okay, so you make the arc on the axis line. And now you give the number on the lines on the various points. So here point P1 and this is P1 dash and this is P2, P2 dash, P3, P3 dash, P4, P4 dash. So like you give the numbers to all the points. After giving the numbers to the various points, giving a name to the various points, I'm going to draw a smooth curve through these all points. So the curve starts from the vertex point and it goes to the point P1 and then P2, P3, P4, P5, P6, P7, P8, P9, P10, P11, P12, and it goes to the another vertex point that is on the axis. So it is taken considered as vertex V dash. So this is the another vertex of the ellipse. In the ellipse, it having two vertex point. So on the left side one vertex and on the right side another vertex. So the curve is meet the axis through the vertex point. So like you draw the ellipse, and in the question they're asking to draw the tangent and normal on the curve at a distance 40 mm from the vertex. Oh, sorry, from the directrix line. So here, this is the directrix line, and this line is the axis line. So in the question, they mention draw a tangent and normal 40 mm from the directrix line. So from the directrix line, I place the scale and I take the reading of 40 mm. So at the curve, so this point, 40 mm is there. Okay, so the point, the distance between the point and the directrix is 40 mm. Okay, so I mark the point, and now I'm going to give the name on this point is P, and then I'm going to connect the point P and F. After that, you place your protractor on the focus point and take angle 90 degree, and draw a line from the point focus point F at an angle 90 degree, and trace a line up to the directrix. And now from the directrix, the point, this point, okay, from this point to the point P, I'm going to trace a line. The name of this line is tangent T T dash. And then you place the protractor over the tangent line, and point P is the center, and take an angle of 90 degree, and now you place the scale on the point P and trace a straight line. So the name of this line is normal line N dash. Here the tangent line never cut the ellipse. And finally, you darken the required portions on the curve, ellipse curve, the tangent line and the normal line, the directrix line and the axis line. After that, you need to mention the dimensioning. So from the focus point, from this line, I'm going to draw one extension line, and I'm going to draw the dimension line, and draw the arrowhead, closed arrowhead. And here the distance between the directrix and focus is 50 mm. So over the line, you write the dimension 50. And here in the bottom, we need to mention the dimension of the tangent and normal. So here from the directrix to this line, the distance is 40 mm. And you also mention this dimension 40. And you never write the unit nearer to the dimension. And finally, you need to write the ellipse over the curve. Okay. Sometimes in the question, they mention name the curve. So that you trace one leader line and put a arrowhead like this, and over the line you write ellipse. And in the bottom of the diagram, the right side corner, bottom of the diagram, you write all dimensions are in mm and scale 1:1. So these things are very important. The dimensioning, the naming on the curve, and the all dimensions are in mm, scale 1:1. And also here, you must write The name of this line, directrix and axis, it is also very important.